Hello everyone. In today's video I'll be trying to show you how to implement simple linear regression in C programming language without using any additional libraries or something else. And throughout this entire series, what I'm planning to do is I'm planning to show you traditional machine learning algorithms implementations in C programming language from scratch. So before we get started, I just want to simply mention how simple linear regression works and then continue with the implementation of it. So here what we will be needing is going to be a simple data set, since in simple linear regression what we do is we use one independent feature and one dependent feature, and based on the dependent feature we try to predict its relative value for the target value. So the main formula of simple linear regression is y hat is equal to a times x plus b, where a is our slope and where b is our intercept. And to calculate slope, what we will be using is going to be sum of x of I minus x mean times y of I minus y mean divided by, again, summation of x of I minus x mean squared. And to calculate slope, what we will be using is going to be y mean minus slope times x mean. And when we plug these two into our formula, prediction formula, it's going to give us the prediction result. But lastly, what I want to also show you is the error that we will get, and for this case I'm going to use mean squared error, of which formula is 1 divided by n, and sum of from I is 1 to n, and it's going to be y of I minus y predicted square. So using these four formulas, implementing them, we will create our simple linear regression algorithm in C. So let's dive into the C++ to start coding. Firstly, I'm going to actually let me first close this console results, and I use standard libraries for input output, and I define my int main function, and I will return 0. You could also return void, but for convenience or convention for all types of C learners, I'm using int main and return 0 as usual. So what I'm going to need is x mean, y mean, and then I need to calculate slope, and then intercept, and then mean squared error. So I will start defining my functions for x mean and y mean. Calculate x mean, and this is going to get a data set, but before that we need to define our data set. And I am going to use a structure, and I will use typedef to name it as data set. So typedef struct, I'm going to get double x and double y, since we will be dealing with continuous values. So I define my data set as length of 5, and it's going to be like 1 3, let's say 5 3 6 6 2, let's say 7 5 and 4 2. Now I have my data set, and now what I need to do is I need to calculate x mean, and then I need to calculate y mean. Since I defined a structure, I need to do it with two different functions, each for one x, and then for y, calculate y mean, and let's fill these functions. Let's write down the operations of them. So this is going to get my data set as an array, and then it's going to get length of my data set, and I will define a sum here which is going to be 0 at the beginning, and an iterator for my for loop, and I will loop through my data set, and I will sum the values inside the dataset using the x values of this dataset array. So sum is going to be, or will be, implemented by dataset of I x, and at the end I will return sum divided by length. So I will just copy this part and paste here. The only thing that I will change is y here, so that I can return both y mean and x mean. But since we use C programming language, we need to prototype these functions, but I also need to give its parameters here as well. So now the first step, double x mean, is going to be equal to calculate x mean. I will send my data set with length of 5, and double y mean is going to be calculate y mean with again dataset and 5. Now we need to write the function for slope, calculate slope. So this is going to get my dataset again as an array, and length, and then x mean and double y mean, and I will just show you in a second why we need these two things. If we come back over here, we need to sum up the values x of y minus x mean, y of y minus y mean. So this is going to give me the denominator, and the squared result of I minus x mean is going to give me the denominator. So that's why actually I needed to send my x mean and y mean into my function. So to do so, what I'm going to do is I will define a double numerator as 0 and double denominator as a 0 as well, and an iterator. So for I is equal to 0, I is less than 5, I plus plus. So numerator is going to be sum of data set of I x minus x mean times data set of I of y minus y mean. So this is going to give me a numerator, and for each iteration, in each step, it's going to be incremented by this result. And then for denominator, what I will need is the square of these two minus x mean, and after I sum up denominator, then I can just call it as den is equal to den times den denominator, and what I can now return is numerator divided by denominator. So first let me just define a prototype of it, and let me come back over here. Double slope is going to be equal to calculate slope. I will give my data set x mean and y mean, and I want to see its results. So if I run this, so it gave me a result, but this result doesn't seem correct. Denominator data set of x of I of x minus x mean. Let's check it again. For each phase we sum up for each values, then square it. So let's do it like this instead of doing this. Data set of I of x minus x mean again. Now let's run it. Yeah, now the result is correct. So now the next step is going to be calculate intercepts, and to do so what I'm going to need is going to be double slope, double x mean, and double y mean, and this is going to return y mean minus slope times x mean. So let's define the prototype of it again, and let's call this intercept with slope x mean, y mean, and let's print this one as well to see if it's correct. Intercept. So we got our result for the intercept as well. So now we can make a prediction simply. So what we can say is that prediction is equal to slope times any x value, for example let's say 1, plus intercept, and we can now print this one as well as prediction. So it predicted 2.3, but as we can guess, there is a small error between our predicted result and the original result, or the original value of this part. So that's why what I'm going to do is I'm going to define mean squared error function, which is going to get my data set, because I will need my original values, and then again in length. And apart from that, what we are going to need is double slope and double intercept. And now what we are going to do is double sum, because sum is going to be our mean squared error result, the summation of it. So I will loop through my data set again, sorry, length I++, and for each time what I'm going to do is I'm going to find y predicted value, which is going to be the same as this part, slope times the value that we are going to give. And for this one, let's say I pred is going to be slope times this, but instead, since we didn't split our dataset into train and test, what we can do is we can use the same dataset to see the result that we will have. So it's going to be, I will use x values of our dataset to see what my intercept and slope impacts or affects my prediction. And after doing this, I will define something as double error, and this is going to be data of y, the original y value, and the predicted y value. And then what I'm going to do is I will sum up these error values with their square, because we are using mean squared error. And then I will return sum divided by length. And if I come over here after defining my mean squared error, and error is going to be mean squared error, and what I need to send is my dataset, length of 5, slope, and intercept. So let's print the error as well. We printed our prediction and we will print our error. Data undeclared. 5 pred is here. Let me define these ones at the beginning instead of inside of here. So this is going to be 0, this is going to be 0. And now let me run my code. I is equal to 0, semicolon. Data set. So yes, we predicted for 1, and our mean squared error function actually gives us 1.04, and for 1 we should have got something like 3, but if we have this much error, and actually if we sum up with this one, it would actually exceed the limit. But as we can see, we have this much wrong results. So instead, what if I use I? No, I can't use that. Since we can't actually split our data into train and test, we can't see the result correctly, but from our dataset, what we found from our intercept and slope, we predict 2.3 for the value of 1, and for the original dataset actually we have this much error for our model. So that's all about this video. I hope that it would actually at least showed you some important points of simple linear regression algorithm and how it's implemented in C. For the next video, what I'm planning to show you is how to implement multiple linear regression, and as I mentioned at the beginning, I'll be trying to show you traditional machine learning algorithms one by one. But for this video, it was all. Thanks for watching, and for the next videos, if you want to see them when I upload them, you can subscribe, and your all comments are welcomed. See you till the next video.